Okay, so this example is going to be similar to the previous one, but this is the case where we can actually end up with two different triangles. Okay, we can end up with two different triangles. So let's set this up. We know that side A is 12, side B is 31, and angle A is 20.5 degrees. So let's set that up. Sine of 20.5 over 12 is equal to, let's find the sine of B over 31. Cross multiply 31 sine of 20.5 over 12 is equal to the sine of B. So let's do the inverse sine. Inverse sine of 31 sine 20.5 over 12. Okay, we get 64 degrees for angle B. Now, let me actually take this back a step before we do the inverse part. Okay, I just want to see what the value of, too many parentheses. Okay, so the value of that 31 sine of 20.5 over 12 was equal to 0.90. Okay, it's equal to 0.90. There are two places where sine can equal 0.90. It can equal that in the first quadrant, which is the 64.783. You can also equal that in the second quadrant. The sine is positive in the first and the second quadrants. So that's why we can end up with two triangles here. Okay, this is the angle in the first quadrant. To find the angle in the second quadrant, we'll use that as our reference angle. Okay, so 180 minus 64.783. B could also be 115.217 degrees. Okay, it can be an acute angle and it can be an obtuse angle. Okay, either one of those will work to build this triangle. Okay, so I've got two cases. Excuse me. I'm going to finish out solving the triangle with this one, and then I will finish out solving the triangle with the other one. And I'll show you that both of them do work. Okay, so if we have 180 degrees minus 20.5 minus 64.783, that means angle C is 94.717. So let's set up our law of sines again to find side C. Calculator's in the way. So 12 sine of 94 be smart, use the answer, divided by the sine of 20.5 gives us that side C is approximately 34.149 meters. Let's make sure that it works out. Okay, check smallest angle, smallest side, biggest angle, biggest side. So in this case, our smallest angle is 20.5, angle A. And 12 meters is the shortest side. The biggest angle is angle C, and the biggest side is side C. Okay, so all that checks out there. Let's work out the other scenario. If B were the obtuse angle, okay, if B were the obtuse angle, then angle C would then be 44. Okay. And then if we set up the law of sines, do I have to write it out? Are y'all okay if I just work it out here? 12 sine of that divided by the sine of 20.5 would give us 23.924 meters for side C. Let's check it, okay? With these three, 20.5, angle A is still our smallest angle, side A is still our smallest side. This time side angle B is the biggest angle, and side B is the biggest side because it's 31, side C is 23. Okay, so it fits right within those parameters, okay? Fits right within those parameters. So you have two solutions when your sine of your angle is positive. Okay, when the sine of your angle is positive, because that is in the first and second quadrant. Let's look back at this one. Okay. Well, that one was positive too. But if we subtracted that, it would end up too big. We wouldn't have enough for that remaining angle. Okay. We wouldn't have enough for a remaining angle there. So the good thing is, I'm not going to throw this at you a lot, okay? I'm not. I'm not going to expect you to come up with two solutions, but I'm going to ask you to practice it right here. But the majority of the time, okay, law of sines, you're going to have one solution, okay? Just every once in a while. I wanted to show this to you just in case there was some crazy problem on the final exam where they want the two solutions. I wanted you to at least see it before, but I just want you to be able to use the law of sines.